All right, in this video we're going to talk about how to classify numbers. So let's move this out of the way. So when we classify numbers, it's no different than what we do any other times in our lives. We classify things, for example, life forms. We've got things like animals versus plants versus this or that. We've got the different instruments in an orchestra, and we classify them. So in math, we can do the same thing with the numbers. This year, we're going to deal with the following classifications, as you see on your screen here. The first group that we deal with are known as counting numbers. And just as the name would suggest, these are the numbers 1, 2, 3, and so on. All the numbers that we naturally would count with. These are also known as the natural numbers because in nature we tend to count things 1, 2, 3, 4. We don't worry so much about halves. The next group changes things just a little bit. And this is called the whole number group. Now the only major difference here is that here we include the number 0. And then we continue with the set that we just saw here, 1, 2, 3, and so on. So the only real difference here between the counting numbers and the whole numbers is this addition of 0. And you may think, wow, that's really stupid and silly, but again, it's a classification. 0 is not a number we count with. Okay, it is a whole number. It follows the same progression here. This is 1 more, this is 1 less. Okay, 1 more, 1 less. So it follows that progression, but it's not a number we count with. So the whole number group basically just gets 0 into the game. All right, so again, counting numbers, what we count with, whole numbers, still the counting numbers with the addition of 0. Then we get to integers. Integers are different. Integers take on not only the counting numbers, not only 0, which again creates that whole number group, but it also adds on the negative whole numbers. So for example, we could have 0, we could have 1, 2, 3, and so on into infinity. Or we can also go now in the other direction. We can talk about negative 1, negative 2, negative 3, and so on. So integers allow for the positive and the negative to occur. Now notice something here. This set of numbers, 1, 2, 3, and so on, fits within this set of numbers with a slight addition. This set of numbers fits within the next set of numbers, again, with some addition. So each group kind of spills into the next. So notice a number like 2, for example, could be called a counting number. That would mean it's also a whole number. That means it's also an integer. But notice negative 2 can only be an integer. It can't be whole and it can't be a counting number. We don't count with negative 2, and it also doesn't belong in the whole number group. The least number available to the whole numbers is 0. So with integers, some of them belong to further groups and others are more unique. The last group, rational numbers. Now we call them rational numbers because of this part right here, ratio, meaning fraction. Ratios are numbers that we can write as either a decimal or as a fraction. So there's all kinds of numbers that can fit here. Obviously all the counting numbers would work. Remember, any whole number we can write as that number over 1. So 2, for example, can be written as a ratio as 2 over 1. 0 is also a rational number. Again, we could put 0 over pretty much any number we want. Let's use 100 this time, and it's, what do you know, rational number. Negative numbers also work. I could put negative 2 over 1, and what do you know, it's a fraction. Decimals also work here. So, for example, the value of 5/10. Okay, we know it also as 1 over 2. Those are rational numbers. Now notice what's interesting about rational numbers. Up until this point, all of these numbers have definite stopping points. 2, 0, negative 2. We can see them. Rational numbers open up a new door. Some of them stop, like for example 2 over 1 or 1 over 2. Other numbers, for example like 1/3, are different. If I try to write this as a decimal, we get 0 decimal 3, 3, 3, 3, 3, 3, and yep, another 3 on into infinity. So some rational numbers are what we call non-terminating, meaning that they don't ever stop. 1/3 is a great example. 1/6 is another number that works. 1/9 is another number that follows that non-terminating. But here's the deal. All rational numbers, not only can they be non-terminating, but in this case, if they are non-terminating, then they have to be repeating. At some point, it has to repeat itself. So for example, 0.33333, obviously it's repeating itself over and over. But a rational number that could work, for example, could be decimal 1, 2, 3, 1, 2, 3, 1, 2, 3, on into infinity. Just simply repeating that 1, 2, 3, 1, 2, 3 business. So this is still rational. We could write this as a fraction, and we'll get into the process of how to do that later. But remember, rational numbers can stop, like say -2, it has a definite endpoint, or it can repeat. If it does repeat, then it must be, or excuse me, if it's non-terminating, meaning it doesn't stop, then it must also repeat itself at some point. Now, sometimes the repetition occurs very quickly, sometimes it takes a little longer, so they're non-terminating, that means they have to be repeating. Now I'm going to draw a line here. So far, all of the numbers that we've talked about here are somewhat related, okay? Counting numbers go with whole numbers fit into integers, integers can fit into rational, but notice not necessarily the other way around. There are some rational numbers, for example, like 1/3, that will not go back into integers or back into whole or back into counting. But these all tend to go together. So, for example, when you go to the family reunion, people tend to look alike, act alike. They like the same foods. Your family, of course, you're all going to have some commonalities. But if you go to a family reunion, sometimes you get those people of your family that, yeah, no one really likes, people don't talk to. You know, maybe everyone in your family has brown hair, and then you got this one family member with red hair. All right, they stick out. They don't seem to belong. Same thing here with irrational numbers. Now, as its name would suggest, irrational, meaning that it cannot be written as a fraction. So one number that you should be very familiar with at this point in your mathematical career is pi. Pi, while like 1/3 doesn't terminate, it doesn't end, pi does something different than 1/3. 1/3 will repeat itself if we write it as a decimal. Pi does not. The best we can do for pi is an approximation. Remember, that's the symbol for approximately. So 3.1415,9, etc., etc. Pi is non-terminating, meaning it doesn't stop, but it's also non-repeating. That's the main difference between irrational and rational. Rational numbers will repeat themselves. Irrational numbers do not. So it will never repeat itself as it goes throughout its cycle, ever. And there's all kinds of numbers that work besides pi. For example, the square root of 2. If you try to type square root of 2 into a calculator with a large enough screen, it would never ever stop. The square root of 5 is also an irrational number. Okay? So does that mean all square roots are irrational? Well, no. Take a look. Let's do this up here. If I take, say, the square root of 25, well, it's a square root. Shouldn't it be irrational? Well, no. The square root of 25 is 5. It could also be -5. Think about it. 5 times 5 is 25. And -5 times -5 is 25. So this value has two answers. Could be positive or negative. But notice both of these are integers, with 5 being a whole number and a counting number as well. Both of these numbers are rational. I can write them as fractions. And if I do write them as fractions, they will terminate. So not irrational. So the only irrational numbers square root-wise are those that are not perfect square roots. So for example, the square root of 16 would fit up here as well. Because again, 4 times 4 is 16, or -4 times -4 is 16. But if I want to take, say, the square root of 17, that's not going to work. We're not going to get this nice, neat, whole, counting, or integer number answer, or even rational number answer. It's going to be irrational. You're going to get a number that's slightly more than 4, and it's never going to stop, never going to repeat. So again, when we're classifying numbers, how do you do it? How do you go through it? Well, I recommend you start with counting numbers. So for example, if I'm looking at the number, say, 9.5, and I want to classify that number, always start at counting. So is this a number that I count with? Well, 9.5, no, I don't count with that, so it's not a counting number. Is it a whole number? Well, no, we said it wasn't a counting number, and it's also not 0, so it can't be a whole number. What about integers? Well, notice integers are just positive or negative whole numbers. Well, we already disqualified it on the whole number count, so it's not an integer. Rational number. Is it a rational number? Very much so. Notice as a decimal, it stops. Okay, it terminates. So great, it fits that requirement. If I write it, I can rewrite it into a fraction or a mixed number. So this is very much a rational number. However, if I took a number, say, like 10, and I asked you to classify it for me, well, we could say more than one thing. 9.5 we could say is rational. But with 10, I could say lots of things. I could say that it's a counting number. I could say that it's a whole number. I could say that it's an integer. There it goes. Or I could say that it's rational and still be right on all parts. So when we're classifying numbers, I recommend that you start with counting, work your way down. And remember, irrational is that group that's going to be, well, hopefully kind of obvious. When you get numbers like pi or numbers like square root of 2, and you realize it's non-terminating, non-repeating, automatically irrational, they don't mix and match with the others. But if it's something else, if it's a rational number, so it fits with one of these groups, then always start at the top here and work your way down. Do I count with it? Is it a whole number? Is it an integer? Is it a rational number? And then you'll be able to better classify your numbers. I hope this helped. If you need more help, or if you're, again, not sure about classifying numbers, please come by in the mornings, talk to me. I'll be more than happy to help you.